All right, let's go ahead and start talking about limiting and excess problems. Let's think about this chemical reaction here where we have 2 tires plus 1 frame produces 1 bike. And the question I'm going to ask you is, well, what if I had 10 tires? How many bikes could I produce? Well, obviously, I'd be able to produce 5 bikes. But what if I had 10 tires in 4 frames? Okay, how many can I produce? If I had 10 tires and 4 frames, how many can I produce? Well, can I still produce 5? And the answer is no, I cannot. Because 4 frames will only make 4 bikes. And so, in this situation, we actually can only make 4 bikes. Yes, 10 tires will make 5 bikes. But this is limiting us. The number of frames we have are limiting us to the number of bikes. And so in this situation, we'll make 4 bikes, and then we will end up having some tires left over, and they will be in excess. And it'll be 2 tires that are left over, because for 4 bikes, we would need 8 tires. And that would leave us 2 tires left over in this situation. So we would say we would have an excess of 2 tires. All right, so let's go ahead and define limiting and excess reactants. So the limiting reactant is the reactant that limits the amount of product that you can produce. If you have 2 different quantities of 2 different reactants, one of them is going to limit how much you can produce. Then we have what is called the excess reactant. What I will say is the excess reactant is the one that you will have leftover of. And so if you have something in excess, that means not all of it will be consumed. You will have some of it left over. The limiting one, you will have none of the limiting one left over. In the example of the bike in the tire, or the frame in the tires were in excess and we had excess tires left over. Now what we're going to do is apply this to chemical reactions. In this situation, notice this problem. It says silicon dioxide is usually quite unreactive but reacts readily with hydrofluoric acid according to the following balanced chemical equation. If 2 moles of hydrofluoric acid are exposed to 4.5 moles of silicon dioxide, what is the limiting reactant? The first thing I want to point out is notice how it's giving us 2 quantities of reactant. So it's giving us a quantity of one reactant and a quantity of another. That should be an indication that this is a limiting excess reaction or limiting excess problem. And what we're going to do is we're going to use what are called ICE tables. And what ICE table stands for, the I stands for your initial moles. The C stands for your change in moles. And the E stands for your ending moles. All right, so ICE tables, it gives you your initial moles, your change in moles, and your ending moles. So go ahead and write that down, and then pause the video and write down this table that I drew here as well. So let's go ahead and talk about how this table works. The first part of it's very easy. What you do is you write your initial moles of all your reactants and products. And so this tells us that we're given 2 moles of this. So we're given 2 moles of the HF, and then we're given 4.5 moles of the silicon dioxide. But what about the products? Well, we're starting off with 0 moles of those. You'll always start off with 0 moles of product. Then what we're going to do is we're going to write the change in moles. So what you want to do is you just want to pick one of your reactants. All right, so I'm just going to go ahead and pick this one. And if all of this is consumed, what would my change be? Well, if all of it is consumed, that means there's no more. So the change would be 4.5 moles. And if you take a look, this is a 1-to-1 ratio. So that means that if 4.5 moles of this were to react, 4.5 moles of this would be added. And so we're subtracting 4.5 moles here because all of it's being consumed and there's no more. And we're adding 4.5 moles here because it is a 1-to-1 ratio. Every 1 mole of this will react and produce 1 mole of that. This here is a 1-to-2 ratio. So for every 1 mole of this, you have 2 moles of your water. So in this situation, you'll be adding 9 moles of water. But what about this right here? This right here, if you are starting with 4.5 moles and all of it reacts, how much of this would you need to react with all of it? And the answer is, well, this is a 1-to-4 ratio. You need 4 times as many. And 4 times as many is going to be 18 moles. It's going to be 18 moles. And so you're going to consume 18 moles. But look at this situation here. Look at this. You don't even have 18 moles. You'll end up with a negative quantity. And this does not make sense. If you are doing these problems and you come across a situation where one of your reactants becomes negative, that means you chose the wrong reactant. And that's okay. All you have to do is just start over. And by erasing all of this. So again, I arbitrarily just picked this one, but now we see that that's not correct. We've got to be picking this one. And so if this one here is going to be completely consumed, we only have 2 moles of it, so it's going to completely consume all 2 moles. We'll notice how this is a 1-to-4 ratio. And so in this situation, that means that we only need 1/4 of this, which is 0.5 moles. Notice how this ends up as 0. Notice how this ends up as 4.0 moles left over. And this is a 4-to-1 ratio, so again, it's going to be producing 1/2 mole. And then this is a 4-to-2 ratio, so it's going to be producing 1 mole. And so again, this is a 4-to-2 ratio, so you see how you're producing half as much in terms of moles. And so what we end up with is this situation here. And so what is the limiting reactant? Well, this is the limiting reactant. The limiting reactant is the one that we have left over, or that we have nothing left over of. It's the one that is completely consumed. This here, these are products, so it can't even be those. And this one right here would be the excess reactant. It will be the one that we have excess leftover amount of. So just to recap real quick, remember when we picked this one right here, we ended up with a negative number here, which we can't end up with a negative quantity. That doesn't make sense. And so if you ever end up with a negative quantity, you just switch to the other one, and then everything will work out. If the problem we're asking, well, how much reactant is produced? Well, 0.5 moles of this were produced, and 1 mole of this was produced. So let's go ahead and do another practice problem. All right, so here we go. We have 36 grams of water is mixed with 167 grams of iron. What is the limiting reactant? And so here's the reaction here. And notice how it's giving us 36 grams of water and 167 grams of this. But what is wrong with what I'm doing already? Well, what's wrong is that these are moles. They're supposed to be in moles. So these are the initial moles, the change in moles, and the ending moles. So we need to take these grams and convert them to moles. And we just go from grams to moles using the molar mass. And we know that 1 mole of water is 18 grams of water. So this is 2 moles of water. And then we know grams to moles here. We know 1 mole is 55.845. And this ends up being 3 moles of iron. So again, what we did is we took the grams and we converted it to moles. And once we convert them to moles, we can then put them in our mole chart. So this is 3 moles of iron, and this is 2 moles of water. So that's our initial moles. And again, we start off with 0 moles of this and 0 moles of that. So the change now, so what I'm going to do is I'm going to randomly pick the first one here. And so if all 3 moles of this reacts, we're going to lose all 3 moles and end up with 0 moles. Okay, so if all of it react, we're going to lose 3 and end up with 0. But how much of this would we need? Well, we know that if we start with 3 moles of iron, and we go from moles of iron to moles of water, this is a 4-to-3 ratio, and this ends up being 4 moles. So 3 moles of iron will require 4 moles, and look at that, we end up with a negative number here. So again, we picked the wrong one. Sometimes you'll pick the right one. Or maybe you'll get to the point to where you can easily recognize which one's going to be the limiting or not. And so in this situation, we picked the wrong one. And so let's go ahead and go back here and start over. Okay, so let's say that we're going to pick this one now, all right? So that means all 2 moles will be consumed. Okay, so that means that we'll end up with 0 moles. And then if we have 2 moles of water, we can go from moles of water to moles of iron, and this ends up being 1.5. So if you do 2 divided by 4 times 3, that's 1.5. And so we would need 1.5 moles of this, and notice how we end up with 1.5 moles left over. So this right here is telling us that this is what's limiting. This is the limiting reactant. And so since this is the limiting reactant, this is what we will use to calculate everything else. Because we know that these 2 moles will be consumed. This is a 4-to-1 ratio. So that means 1/4 of these moles will be produced. So you end up with 0.5 moles. Here, this is a 4-to-4 ratio, so it's like a 1-to-1 ratio, so you end up with 2 moles being produced, and this is okay. So this is our ending amount. Now notice how this is what's limiting us. We end up with 0. This is in excess. We end up with some left over. This here is how much product is produced. And so let's go ahead and answer this question. The question is number 2. It says, what is limiting us? So what reactant is limiting us? Well, again, it's a reactant that's limiting, not a product. So you can automatically cross out the products. And what's limiting us is the water. What is the mass in grams of black iron oxide produced? This here is black iron oxide, and according to this, we're producing 0.5 grams of the black iron oxide. And so we need to take those 0.5 moles, and we need to take those 0.5 moles and convert them to grams. And so here's the setup for converting the moles of black iron oxide, which is the Fe3O4. And I've calculated the molar mass already for you. So you just need to type this in the calculator, and it ends up being 115.185 grams of the black iron oxide. And so that's what we end up putting here. Except we need to make sure we have correct sig figs. And so we're starting with 3 sig figs, so we need to be ending with 3 sig figs. So these are 3 sig figs here. And so we end up with 115 grams of black iron oxide. Okay. Now it says, what mass in grams of excess reactants remain? Okay, so what is the excess reactant? Well, this is the excess reactant. That's the reactant that we have some left over of. And notice we have 1.5 moles left over. Well, again, it's asking for it in grams, so you just need to take the moles and convert it to grams. And so here's the setup for you, converting from moles to grams of iron. And so we end up with 83.76, which rounds up to 83.8. Because again, all the numbers that we have are 3 sig figs, so we should end with 3 sig figs. All right. And let's just put a big smiley face here because this was a giant problem. Before I end this video, what I want to point out is this problem right here has got a lot going on with it. Notice how it's first asking you what is limiting, and then asks you how much is being produced of a particular product, and then it asks you how many grams are left over. Problems on the exam are probably going to ask one of these things rather than all 3 of them. So just keep that in mind. But the ICE tables are really nice because you're writing what you start off with. You're writing how much is changing and then how much you're ending with. And the fact that you're writing how many moles you're ending with, it really allows you to then take that and convert it to grams for whatever problem it's going to give you. And so really, the fact that you were able to figure this last part out made it to where all the other calculations are pretty straightforward. So this does come with practice. We'll have some practice in class. There's the guided or the independent practice problems that there's an answer key for, so definitely watch those. And come with questions. If you are unsure of something, definitely ask some questions. You guys have a great day. I'll see you in class.